Let's take some notes. So in your notes, you should write this problem down. We're going to work a 7-step problem. So make sure you have room to work the 7 steps. So it says a person does 2,000 joules of work with a force of 1.5 newtons as they push a box across the floor. How far did they push the box? I'm going to start working the problem. So when we encounter a math problem, we're going to do our R2D2 guess. So we're going to read twice. So a person does 2,000 joules of work with the force of 1.5 newtons as they push a box across the floor. How far did they push the box? What I'm reading for the first time, remember, is just what are we kind of dealing with? So this one's obviously about work and force. So I'm already going, okay, this is what it's dealing with, all that kind of stuff. Later this week, when we add energy, work and energy are connected. Okay, they are 2 sides of the same coin, almost, kind of, sort of. So it's really important that you get an idea of what kind of arena are you playing in here. Okay, so we are going to be talking about work. I'm going to read it a second time. This time I'm going to mark my values that I've been given. So I've been given 2,000 joules of work. So that's easy label. They tell me it's work. That's supposed to be a W. With a force of 1.5 newtons. So that's a force. As they push a box across the floor. How far, and that's a distance, did they push the box? Okay, pretty easy. So I'm going to draw my picture. I'm going to actually skip drawing the stick figure pushing the box. But we do have a box being pushed, and it has a force applied of 1.5 newtons. And I almost didn't leave room for this, but we're going to push it over a distance equal question mark. And in that process, we're going to do a total work of 2,000 joules. 2,000 joules. Okay, so I've read twice, I've drawn. My drawing tells a story, so I push a box from here to here. I do 2,000 joules, and I use this kind of a force, and we're looking for distance. So I've drawn twice, R2D2, and now I'm going to guess givens. Work equals 2,000 joules. Force equals 1.5 newtons. And then my unknown. Distance equals question mark. Now, for the next step, you're going to want to keep working vertically down the page. I don't have room to do that, so I'm actually going to work over here on the side. Okay, so we're going to pick an equation. So we're at the equation step. Given unknown equation, substitute and solve. That's our guess, R2D2 guess equation. So I need to go to the equation sheet. Yes, we might have an idea of what equation we're using because we've only talked about one for this unit, but let's make sure we know where the equation sheet is. So you go to your page. Over here on the left side, you have a little link that says files. You should click on files, go to the equation sheet, and then click on the equation sheet, and your equation sheet should pop up. And you will notice we are looking for an equation that has work, force, and distance. Up to this point, we've looked for an equation that says distance equals, and then we look for the equation. Well, guess what? We are not anywhere else except here in the energy, and there is no distance equals equation, okay? There is no equation in this little section that says D equals something. So we are moving, we're basically growing up in our physics. We started off just giving you all the different equations, and you just picked the one that had the variable missing equals whatever the other variables were. We're not doing that anymore. So there's an equation for work. The equation for work is work equals force times distance. Okay, so, and yes, you're exactly right, Brianna, but there are some students who haven't seen that. So I'm going to show everybody how to do that. Okay, so work equals force times distance. This means force times D. We can write it force times D. And it's silly that it might seem silly that I'm explaining this, but there are some of you that are dividing in your calculator when you should be multiplying. I don't know why you're dividing, but you should be multiplying when you plug in the numbers for this equation. Okay, so force times distance. Work equals force times distance. So in traditional physics, like over here with our constant speed and all those, we usually only give you like 2 equations, and then you have to do all the algebra yourself, okay? But many times when we're teaching freshmen, you don't have the math skills to do that necessarily, so we want to kind of baby step and walk you into where we're doing the algebra that we want to do. Okay, so we've got this equation. I'm going to go back to my problem here. Go back to my problem. And I'm going to write the equation. Work equals force times distance. Now, there are a couple ways to go from here, and I'm going to show you the way that I prefer to do it. And it's not necessarily necessary for this simple equation, but for a more advanced equation, it actually is very helpful to do it the way I'm going to show you how to do it. So the next step is substitute. So I'm actually going to go ahead and substitute in the numbers that I have. Some people would actually do the algebra first and then plug in the numbers. I prefer to plug in the numbers first and then do my algebra, because then I don't mess up which variable I'm actually trying to solve for. So force is 1.5 newtons, and I'm looking for my distance. Oh, almost forgot my parentheses. Okay. So what I have is work, 2,000 joules, work equals force times distance. Now it should be pretty obvious what I need to do for algebra. And for those of you that don't see it quite yet, just remember, this is the same thing as saying 2,000 equals 1.5 times x, okay? So how would I solve for x? Well, I would divide both sides, right? So I'm gonna do that. But instead of x, we're using the letter D. It's the same thing, we're just using a different letter. Okay, so 1.5 on both sides, 1.5 on both sides, and now I have D equals. Please use a calculator. Don't try to do this in your head, okay? And I actually have been using Desmos calculator, scientific calculator, because it does parentheses. So 2,000 divided by, what is it, 1.5 equals, what's the units for meters? Misspoke, I told you. 1,333.33 meters is our distance. So we have given unknown equation, substitute, and solve. We have solved. This is our final answer. I have a number, I have units. I showed my work. I showed all of my algebra. You should show your steps. And equation, unknown, givens. I've done my drawing. I've labeled everything. Check. I've done all my work. Questions on this specific problem. You will get a chance to ask questions about the homework in just a second. But if you have questions about what I just showed you, okay, so I got 2 great questions. What place do you round to? The general rule of thumb is 2 decimal places. If you go to 2 decimal places, then usually you will be good enough. There's actually a special rule on what those are, and it's quite complicated, and we're not going to do the rules on how to round, okay? It's called significant figures. So we're not going to be dealing with that. Just round to 2 decimal places if you have a decimal. Okay, parentheses. Do I really need parentheses? For this problem, yeah, I probably could get away without using parentheses, because it's pretty clear what's going on, right? 1.5D, parentheses, okay, maybe not, okay? However, when we start doing this same process with force times distance equals 1/2 mv squared, now I really do need to do parentheses, because I've got a force, I've got my distance, I've got a half, I've got m, I've got v, but v is squared. We really need to use the parentheses because we want to make sure that only the v is squared, only this is happening, and the parentheses will keep us straight. So I prefer to use parentheses all the time because then when I get to this harder problem, I don't have to remember to use them, okay? I just use them all the time, okay? And just remember, what is the purpose of the parentheses? It's to tell us that we've substituted in a number there, okay? So the only reason I'm putting a parentheses here is because that is work. Work is 2,000 joules and force is 1.5 newtons. So that's in parentheses. So I go over here and I find that number and that goes into the parentheses, okay? All righty. Any other questions about this specific problem? All right. I'm going to clear this drawing out. I am recording this little session and I will edit out stuff and I will post just this section later today.